thanks for joining this session 3 of Arista Knowledge. We're going to talk today about a very exciting topic, the monitoring, the assessment of zinc oxide surge arresters, and how to detect efficiently potential unsafe surge arresters. Also, it's a kind of latest update on the state-of-the-art ZNO surge arrestor monitoring solution. And the device, the solution from Tridelta Meidensha is called the smartCOUNT. And this is what we're going to talk today. So I will take the lead for the presentation. Philip Rajke, my colleague from R&D, is sitting next to me and will be supporting. So then let's start. So this is the agenda for the next 90 minutes. We will keep 30 minutes for the Q&A, the question and answers. Please pay attention, and if you're familiar with Zoom, you know this already. You have this specific Q&A section in the Zoom webinar. We highly recommend to use this section and not the chat. Because after the presentation, after the session, Caroline will collect everything and send it to you per email, so that you get the video, you get the slides, but also all the questions that have been addressed during this presentation. So please use this Q&A section. So for the agenda, we will the first part of the presentation will be mainly focused on the failure modes and how we detect potential safe arresters by using a specific methods. Then we will dive a little bit deeper on the smartCOUNT solution itself, and with a cloud demonstration to show you how to access to the clouds and how to use it, and show some application worldwide. And then we will dive a little bit deeper on the current patterns that helps you to take decision. And yeah, and then we will conclude. And we hope we'll get exciting questions from the audience. Feel free to ask all your questions. And Philip is very proactive to answer them also during in written during the presentation. So before we start, I would like to inform you also about a nice event last month. In October, we have celebrated the 60 years anniversary of the first production of surge arresters in 1961. So the picture you see here on the left is the same building where we are producing today the surge arresters. And of course, at that time, it was not zinc oxide. It was silicon carbide surge arresters, different type of technology. And on the right side, in 1989, you can see the zinc oxide production. So this was an important event for us last month that we have celebrated this date. About the when we talk about monitoring solution, just to be a little bit more specific with the field of application, in 99% of the time, 99% of the application, we are talking about high voltage surge arresters. We are talking about surge arresters which are used to protect valuable assets like power transformers, or also some sensitive installation like cable termination, where you want to make sure that the surge arresters protect your equipment with a high reliability. So just to say that, it's quite unusual to find monitoring on distribution class and some medium voltage application. So as an introduction, we will start with some typical question that we receive in general when we have discussion about monitoring, when we have the chance to visit our clients, to talk to the users and utilities. The main question is, why should I monitor my surge arresters? Does it make sense? Is that needed? There are a lot of utilities which are not monitoring the surge arresters. Another typical statement that we get also is, I can simply replace the surge arrestor when it fails. I don't need to monitor. So of course, this is not exactly like that. The surge arrestor is not a fuse. And another statement, the cost of the monitoring device are higher than the surge arrestor itself. That's also something that we hear quite often, and this is understandable that people think like that, because let's say there have been a lot of things happening in the last 15 years regarding the monitoring of surge arrestors. Therefore, it's, let's say, the first generation and some existing solution today are quite expensive, and this is what Tridelta Meidensha is trying to change today. So we will try to answer those questions during the presentation. And yeah, and again, feel free to ask your question in the Q&A section. I see we have more participants joining us. Please use the Q&A section and feel free to ask anything. There is no stupid question, especially when it comes to monitoring. That's yeah, a topic with a lot of there's some complexity behind. So I'm sure that among the audience, many of you are quite familiar with the traditional surge counters, which are still used and still specified in many countries. Those devices are quite outdated technology. They are electromechanical devices with very limited function. And of course, we want to make a distinction here, because the idea of monitoring for surge arrestors is to be proactive in maintenance. You need an efficient condition assessment of your arrestors, what is happening with your arrestors. Therefore, it's important to make a distinction that this is absolutely not comparable with those old devices. The first reason is the leakage current measurement on those devices is a total leakage current, which is an RMS value, which does not help to get relevant information or meaningful information. The other one is the counter itself, that will give you the number of over voltages that could occur on the surge arrestor on your specific phase. This is also just a number. It does not provide you the time, the date, and the amplitude of the surge, of the impulse. So it's pretty limited. And also, as you may know, many of the surge counter are outsourced in local countries at the expenses of quality, and this could lead also to moisture ingress and failures. So it does not really make sense to use a device that will operate only for a few years, especially if the information which are provided are not very meaningful. So this was just for the introduction. It's important, before we talk about failure modes and about the device, the smartCOUNT itself, it's important to talk about the currents, the leakage currents. As you know, the leakage currents, they could be our enemies, but they are also our allies, because they help us to actually assess the condition, to provide information. In the case of the smartCOUNT, it's even better. We go even further, because the leakage current can power the device itself. So we have two groups of currents. Of course, all currents are influenced by the boundary condition, the applied voltage on the system, proximity and voltage applied to other objects in the vicinity. So let's start with on the left side. Let's start with the internal currents. It's important to make some definition to make sure that we understand which currents are doing what and where they are coming from. So when we talk about internal currents, we're talking about the currents that is flowing through the metal oxide varistors, the zinc oxide, ZNO, which is governed by the capacitances and the resistances of the ZNO varistors. So the total leakage current under normal condition is mainly capacitive, and the resistive current is projected from the third harmonic and used to determine the health condition of the ZNO varistors. Important to mention here is that if you you will see on the next part of the presentation, which is used is the peak current, the peak value of the total leakage current, which is much more relevant, important than the RMS value. But under normal condition, the current which is flowing through the varistors is capacitive, and what we need to assess the health condition of the arrestor is actually the resistive current. And the only way to get a reliable picture of this resistive current is to look at the third harmonic. And this is a method of assessment which is also defined in the IEC user guide 699-5. Okay, so then we have on the right side, we have the external currents, external surface currents, which are governed by the insulation material, the arrestor design, and the environmental condition as pollution and temperature. So as you know, you have porcelain housings, you have silicone housing, different kind of design, cage design, tube design, wrap design, and of course, different kind of environment depending on the countries, the climate, and the temperature. Therefore, you can expect different currents. One of them is the external current on the surface of the insulator, which can change, fluctuate greatly depending on the contamination, the pollution layer on the surface. The other very important external current is the one on the surface of the MOV varistors. So it's inside the surge arrestors, but it's kind of external because it's a surface current on the MOV coating, on the MOV surface. And this current depends mainly on the moisture ingress, the humidity condition, and it's of course related to the temperature fluctuation, which can make some condensation. Okay, so I hope this part is clear because it's quite important to go to the next step. So next step is to let's say to understand the different failure modes that you can face on surge arrestors. So as you know, the job of the surge arrestors is to handle transient overvoltages. And therefore, there are a couple of ratings which are important to make sure that the arrestor can withstand the surge duties and the fluctuation of the temporary overvoltage. So what we want to show here is that the smartCOUNT, let's say the monitoring solution, which has the capability to measure, to evaluate the resistive current, can help you to evaluate the MOV aging, to assess the health condition, which are a consequence of those, let's say, failure modes that could occur on the surge arrestors. A thermal runaway is a possible failure in relation to the energy rating of the arrestor. Also, an excessive charge transfer could lead to a failure of the arrestor. So normally, if the surge arrestor is properly selected and properly dimensioned by the manufacturers and properly tested, this should not happen. But in reality, the world is not perfect. You cannot predict everything. And the main cause of MOV aging is actually the surge duties and the stress coming from the system, which could lead to an evolution of the resistive current. So in that way, the smartCOUNT can help you to assess, to look at the MOV aging as a consequence. So to summarize the three main, or not to summarize, but say to present clearly the three typical failure modes then the smartCOUNT can detect, and that can provide clear information to the users. We have the MOV aging, ZNO degradation, which I just mentioned on the previous slide. There are plenty of reasons for having MOV aging. Under normal condition, MOV zinc oxide blocks do not age. This is tested according to accelerated aging test, and all specialists, all MOV manufacturers will tell you that an MOV block does not age under normal condition. But as I explained below, they could be a different stress, different search duties that could affect. And therefore, MOV aging happens, especially on old search arresters, as you will see at the end of the presentation, some typical cases. And you have the possibility to measure the resistive current and to assess the health condition. Okay, that's the first one. The second one is the moisture ingress, which is related to the humidity inside the search arrestor on the surface of the MOV block. Of course, you can prevent this. There are a lot of different design on the market, a lot of different qualities. The design of the search arrestor is made to prevent moisture ingress, but again, the world is not perfect, and we have seen from our experience from the field experience that moisture ingress is a very typical failure for search arresters. Whatever is the design you are using, even if it's a directly molded gauge design or a hollow core porcelain or hollow core polymer. So it's a very common issue, and you can assess the surface current on the block in order to give you reliable, it's a meaningful information. This is the second point. So the third point, the third failure mode that can be assessed by the smartCOUNT is the contamination and the pollution on the surface of the insulator. As you know, especially in some countries where pollution is a big issue, where some utilities specify very high creepage distance or using RTV coating to improve tracking on erosion performance, or some utilities are only using polymer arresters with silicone rubber to prevent, let's say, contamination, tracking and erosion, and of course, potential external flashover that nobody wants to have on his system, on his search arresters. So everybody knows that this is a typical issue, and even though there are some methods to prevent this, it is possible to assess the contamination, to measure the pollution layer by looking at the current, which is flowing on the surface of the insulator, and this helps you to give you a clear signal or a clear notification when you have to clean the search arrestor. And also it's an important information because you may know that the pollution layer can affect the grounding performance, which means the voltage distribution of the search arrestor. So you know that some search arresters are equipped with a grading ring, and this grading ring helps for the voltage distribution along the MOV column. Sometimes it's not needed, sometimes it's needed, depending on the voltage level, depending on the height of the arrestor. And for porcelain search arresters, actually the performance, the thermal performance are affected by this pollution layer. So it's even more important for porcelain arresters to have reliable information about that. Okay, so here's a summary of the failure modes which can be detected by the smartCOUNT. So to summarize, degradation of zinc oxide varistors, where there is a risk of thermal runaway, and we are using the resistive current for that. because the third harmonic method. Second one, humidity, moisture ingress on the surface of the MOV block, which makes inner surface current where you have a risk of inner flashover that you want to prevent. Then the surface pollution, contamination, where you have an outer surface current and a risk of external flashover that you want to prevent. So about the smartCOUNT itself, maybe some of you are already familiar with the device, and we are trying to make it to design it and to make it as simple as possible, even though it's kind of complex and a lot of research behind, a lot of experience feedback. It's quite simple. So basically, you have a sensor which is connected on the arrestor. So the basically like the surge counters, the smartCOUNT is connected in series to the ground lead. And so you have the sensor directly connected on the surge arrestor. Well, it's preferable to connect it on the surge arrestor. It's not mandatory as long as you respect the recommendation for installation and that the current goes through the sensor. And on the current version of the smartCOUNT, we are using a transponder pad where we collect the data with a smartphone and the app of Tridelta Meidensha that you can download from the App Store. And this app will help you then to upload the data to the cloud, and you can access the cloud from every device, from any device. This the smartCOUNT, the sensor, is directly is self-powered by the leakage current of the surge arrestors. You don't need any battery, you don't need any external supply or anything like that. It's very flexible because you can use it on every type of surge arrestor, every brand. There is no restriction for that. We call it maintenance free because basically you don't need a battery, and this is pretty robust equipment that has been tested in very tough environment with a very reliable sealing system. So because of that, it's IP67 approved and quite strong to resist high temperature, strong weather condition, and UV light. You have an easy data collection by using the smartphone. So there will be an evolution of this device because I'm sure some question will come also from the audience. I will talk a little bit more at the end of the presentation about the next evolution of smartCOUNT, where of course the data collection needs to be automated. Very important when you look for monitoring solution is this resistive current calculation by using the third harmonic method, and you need also to consider reliable automatic error compensation because this third harmonic method can be influenced by harmonic pollution. So it's quite important to have a reliable calculation, and Philip has done a great job for that to make sure that the information which are measured are reliable, are a clear picture of what is flowing through the surge arrestor. So it's also quite important because not every monitoring solution has this reliable and precise measurement of the resistive current calculation. And this is the only way, including temperature, but this is another topic, maybe we'll talk in the questions. The resistive current is the only way with the temperature measurement to assess the condition of the ZNO block. And then we have, of course, some important features, which is the resolution of the leakage current to be precise in the measurement, and a large range of possibility when it comes to impulse counting, impulse measurement. Yeah, and you have access online to once the data are uploaded to the cloud, you can access to the cloud from everywhere, and you can define, you can also customize the cloud for your specific application, for your specific surge arrestors. You can configure some specific alerts notification per email, per SMS, to show you the critical surge arrestor condition. And of course, you have always full support from the sales and the R&D team here in Helmsdorf, Germany, in case of question for installation or for understanding the information that you read on the cloud. Okay, now let's do a demo. Let's go to the cloud. So once you get your smartCOUNT, you will get an access to the cloud. You will get a username and a password. So what I'm showing you here is the website, so smartcount.info. We just for your information, we are now this cloud is available in Spanish language, and there will be, you can go here, Espanol. There will be a webinar session in Spanish very soon. So yeah, you go to login, or before, sorry. So you can download, you can see a lot of information about the smartCOUNT on the website. If you scroll down, you can also see, you can download smartCOUNT user guide. A lot of information in this user guide. It's very complete, very informative. So if you want to, after this webinar, if you want to learn more, I recommend you to go through the user guide. Okay, so once you have you received your smartCOUNT and you have configured them, then you can go to the login. This is just a demo to show you. So you get your username, password, then you jump to the cloud. You have this arrestor overview. Move this up. I'll put it here. So you have this arrestor overview where you see all the surge arrestors with the related information as the ID, the location, the site, position in your substation, system voltage and product type, all relevant information that you need. And in red, it means that it's critical. This the threshold, the parameters for the criticity is something you can also define and adapt depending on your expectation. So this is the overview part. You can also have you can also find some additional information, some support, user guides, also the installation video. There is if you want to see a real life installation, there is also a video. So I go back to the overview. I select a specific surge arrestor. So for example, we have some typical cases for the demo where you have a degradation. So ZNO degradation means that the resistive current, the trend of the resistive current goes higher and higher, as you can see, and with the blue curve is the resistive current that you can display, like here. You can also show the trend that gives you a clear information that something wrong is going on. And what you see in green here is the peak current, the total peak current. And you can always show the trend, and here also is what I mentioned before, the threshold for the critical values that can be also customized. Yeah, and you can see all the details, all the information which are displayed here are of course available as data, and you can export a lot of possibilities. I show you another example where we have also some lightning impulses. You can see here a specific lightning impulse at 10 kA, another one at 1 kA. And you can decide to display or not display. Yeah, and the same here, you can see the details of the impulse current measurement. You can see the amplitude, the date, and the time, which is quite quite useful. Okay, that's for the cloud demonstration. Go back here. Okay, so now I will talk a little bit about the experience of Tridelta Meidensha worldwide with this monitoring solution, because this is not something completely new. This has been released officially in 2019. But before that, we had a lot of experience, feedback, pilot project in many different countries to make sure that the device itself and the solution is reliable and can really assess the condition and bring meaningful information. So we had today we can claim 4 or 5 years experience in 20 different countries, especially in tough environment, as we can see on the left side in Saudi Arabia, where you have, let's say, this the region of Saudi Arabia is known for this very high pollution level with intense UV radiation and very high temperature. And so smart guns are running there on the Tridelta arresters and other brands. It's quite interesting. The main purpose for the utility is to assess, of course, the contamination, so the external current on the surface of the insulators. Let's say that's the main motivation, but of course they have a complete assessment. Yeah, and also in Brazil, for example, as you can see on the right side, there are some installation on polymer arresters in tropical and coastal climate, where also the weather conditions are quite tough. Some other examples, different environment, different countries. I mentioned at the beginning that the main application for monitoring of surge arresters is in general high voltage, and in the substation for power transformers or cable termination, where you want to protect your, or let's say you want to have a reliable information about the protection of your valuable assets. But in some cases, you can see utilities which are very interested in having information about transmission line arresters. So you can see on this picture the installation of the smartCOUNT. So it's not easy, of course, but it really helps them to have a continuous assessment. And as you know, Vietnam is a country with a high chironic level, so a high lightning density, where the utilities are facing outages, and it's quite important for them to monitor some of the non-gap line arresters. Another installation, another example in Slovakia, where the atmospheric condition are quite special, with a lot of moisture and ice, low temperature and rain. And yeah, the smartCOUNT is running well since this installation. Okay, now let's dive a little bit deeper on the assessment of the different failure modes and the detection methods. So as I mentioned before, we have three typical failure modes that the smartCOUNT can detect, which is MOV aging, moisture ingress, and surface pollution. So here is let's say an example, or let's say a typical understanding of what does it mean when you have a contamination or surface pollution. So we are looking at the peak current In such cases, the resistive current is not really relevant, not really helpful. It's kind of stable, even though you see a small fluctuation here. But the main indicator and the reliable indicator is the peak current. So the peak value of the total leakage current, which can give you a reliable information about the pollution. And as you can see on this, you see that there is a kind of recurring peak current where the amplitude is growing with the time. And this is a typical indication that the pollution is accumulating and the current is rising on the surface of the insulator. So with such information, you can decide whether you need to clean your insulator or not. So the other failure mode is moisture ingress, humidity, and this is quite common. This is the feedback we've got from the field, and when we have the chance, also the opportunity to investigate and to make root cause analysis on failed arrestor, or when we replace them after monitoring. Moisture ingress is a typical failure of surge arresters. So there is in such case, there is a conductive layer but only a slightly fluctuating resistive current. So again, this also for this failure mode, the main indicator is the peak current, the peak value of the total leakage current. And you can see this fluctuation going up and down. And by looking at the trend, you can decide whether you have reached a critical point where the surge arrestor needs to be replaced. Okay, then now I think you are familiar now with the concept. So MOV aging, ZNO degradation can be assessed by looking at the resistive current, which is a projection of the third harmonic. And the degradation takes place in different stages. And this is quite important. There must be different, as we mentioned, different cause, different root cause, different reason for having a degradation of MOVs. It could be several blocks which are losing their performance. It could be also one block that fails. But as you know, the surge arresters are the active part of the surge arresters, or the MOV staking. And the MOV staking consists of several blocks. And in some cases, especially for high voltage, extra high voltage, you have let's say a high quantity of block. If one block fails, the surge arrestor can still function, can work, but you will see a change in the resistive current. So it can start a degradation, or let's say MOV aging, ZNO degradation, until you reach the overload. The failure can happen over, let's say, a long period of time, and it goes always through different steps. And the idea here is to have a kind of mid-term, long-term assessment. So in general, it's not something that you will assess like one shot, one picture, one day. Oh, here's my current. You need to look at the trend, at the evolution of the resistive current. And in such cases, as you can see, the smartCOUNT really helps you to reach a level, a critical level where you exceed the minimum acceptable resistive current for the MOV varistors, and this gives you a signal that the surge arrestor must be replaced. So the value itself is important, and of course, what I wanted to say is that the trend is also an important information. Okay, so to make it to make it very clear for the audience, for everybody, here is a summary of the 3 typical failures with the pattern of the current, with the trend. Of course, the reality is always a little bit more complex, but we try to be simple. Let's say beyond the complexity, we try to remain a little bit simple to make sure that everybody understands the concept. So as you can see, for a typical surface pollution on the insulator, you have this peak current, which is the main indicator, and this is this spike. You have a periodical spiked fluctuation of the current, but the peak value is increasing over the time. And this is an information that you need to check your surge arrestor, and probably you have to clean it. And if the current goes back, it's a clear confirmation that this was the right assessment and you have done the right thing. Then moisture ingress on the surface of the MOV block, you have a similar fluctuation with a kind of stable peak value, but a constant fluctuation of the peak current, of the peak value of the total leakage current, but still a slow change in the resistive current. And if you are sure that the surface of the arrestor is clean, which means that those spikes are not influenced by the external pollution, then it's a clear signal that you are having moisture ingress in your surge arrestor. And in that case, it's highly recommended to replace it. And of course, you can always contact the manufacturer to define some typical threshold in order to take the right decision on time. Then the third one, MOV aging, ZNO degradation, where you see this successive rising resistive currents, but also a peak current. And here's a good example to understand why we need to look at the peak current and not at the RMS value. Because when the resistive current is increasing, this does not influence that much the RMS value of the total leakage current, but it will influence the peak current significantly. Yeah, so as I mentioned before, the trend is important. Of course, there is always a critical limit when if you exceed the nominal value, which is, let's say, known from the characteristic of the block that manufacturers know very well. If you exceed this value, it's definitely a critical point, but also the trend is a reliable information to take a decision whether you replace the arrestor or not. So to conclude, to summarize, the assessment of the behavior of the leakage current trend is the key for appropriate arrestor monitoring. Here are some examples. Just looking at the time, it's okay. Here's an example, a real example we had in Asian countries where smart counts were installed, and values of the current from the cloud were reported to us, and we were requested to provide a report recommendation. So typically here you have a combination of pollution, external pollution, with humidity condensation inside the surge arrestors. So in blue, you can see that the resistive current is quite stable, but there is a trend of the peak current, of the peak value of the total leakage current, and the trend goes higher and higher. And you also have this daily fluctuation, which give you also a signal that there is some condensation, some humidity. You know, those daily cycles where you have more humidity in the morning than during the day. That also helps you to find out that something is happening. Yeah, so in such case, recommend if cleaning the surface of the arrestor does not help to have a significant improvement of the daily fluctuation of the peak current, then we provide a recommendation to replace the arrestor. And of course, it's always important for utilities when they start doing this to make a root cause analysis and to check the surge arrestor, right? Because this is what we want to do. And this is the next example. So this is another project where smartCOUNT were installed somewhere in Southeast Asia on very old porcelain surge arresters. As you can see, the values are quite terrible. You have a peak current of 3 milliamps, which is quite high, and a resistive current in the range of let's say 600, 700 microamps. So when you see such things, I think you don't have to to elaborate that much. It's a clear signal that something is going really wrong. And so guess what happened here? The utility decided to replace the surge arrestor. And what you see here is the nominal value of a new surge arrestor, which was in operation. So these values are completely normal, completely acceptable. You have a peak current below 1 milliamp, and you have a very small resistive current and a normal condition. And here is the actually the root cause analysis. So we had the possibility to investigate afterwards the units that were very suspicious and that were replaced. So as you can see, here is a combination of different things. On the right side, you see this this is the active part. So this is a very old design. I'm not sure you find such things on the market today, but the MOV stacking is wrapped with a kind of textile material, and there is a huge cut hole inside the MOV structure. So this is definitely the reason of the high resistive current, the ZNO degradation, MOV aging. So it's definitely a clear failure. And on the left side, we see a lot of corrosion. And actually, it was clear when the arrestor was disassembled that there was a lot of moisture ingress, humidity ingress. So there was a combination of different factors where the surge arrestor is really in bad condition. And of course, you don't want to have this kind of surge arrestors protecting your assets, right? So for us, it was also a nice success because, you know, when you do monitoring, the purpose of monitoring is to reach a concrete result. It's not only to sell monitoring devices. So for us, it was really a success that what we are doing makes a lot of sense for the industry. So now I go back to the questions I had at the beginning. So why should I monitor my surge arresters? So exactly for that reason, as you saw on the previous slide. If the surge arresters are affected by surface pollution, by humidity ingress or ZNO degradation, I mean, there is the high risk that the surge arrestor fails, but also that the surge arrestor is not capable to protect the connected primary equipment, which could be very expensive power transformers, for example, or a very sensitive point between overhead line and the cables, where you don't want to damage your cables because nobody wants to replace them. You want them to last for a couple of years. So yeah, if the surge arrestor is not capable to protect, of course, there is a risk. There is always a risk of lightning over voltages or switching over voltages, and that can affect your primary equipment. And your primary equipment, especially power transformers, or design the insulation level of the power transformers, or design based on the protection level of the arrestor. So if you cannot guarantee the protection level of the arrestor and the proper performance of the arrestor, you don't protect your equipment. And of course, this is, I think, the main thing. Transformers are expensive, and you want to prevent failures and breakdown. And this is possible to avoid those outages, all the costs which are related to the outage, which are related to the maintenance, and also possible penalties that the utilities have to pay depending on the contract and the users they are supplying. So, which means that you cannot simply replace a surge arrestor when it fails, right? It does not really make sense. So a typical statement, as I mentioned before, is that that we receive very often is the cost of the monitoring device is higher than the surge arrestor itself. So if you still think that this information is true, I highly recommend you to get in touch with us, and we can show you that this is not the case anymore, that we are able to provide cost-effective solutions which are reliable and which are also, in the case of Tridelta Meidensha, it's a in-house cost-optimized design with a local supply chain, and this was in the definition of the specification. It was important. It does not make sense to make a monitoring which is extremely expensive. And I know that some utilities, some EPC contractors, many people think that those monitoring solutions are not very useful and are quite expensive. And I believe that, I mean, there are plenty of reasons for that. And it's true that the first generation, like 15 years ago, 10 years ago, the first generation of monitoring devices when are not reliable as, let's say, we're not reliable as today, and not effective also to collect the data and to evaluate the data. But they were also expensive, and which is also normal when you launch a new product on the market. But also now, when we see the evolution of today's generation of monitoring devices, I mean, the trend is to make, let's say, reliable solution, but we believe that those solutions are still expensive. Yeah, because for us they are not really optimized, they're not really cost optimized. And when you have such, and there are probably great solution that you can find on the market, but this is not the philosophy of Tridelta, at least, because we believe that monitoring, there is really a trend for monitoring. I mean, that's a fact, right? In the high voltage industry, there is a trend for monitoring, and that many utilities are reluctant to go into monitoring, because actually monitoring solution could be quite costly, and you are not sure about the result, like what I will get. So for us, it was very important to design something which is cost efficient and which is also reliable, and that provides meaningful information. Then, before we go to the conclusion, the time is good, some information also about the extensive testing which are performed on the smartCOUNT, and also about the product itself. As I mentioned, we have a local supply chain. This is quite important for us. The supplier of the electronic components is a company which is 30 minutes from our factory. So it's made. The all smartCOUNT is made in Germany, and this supplier has advanced technology in the field of electronics. They're using state-of-the-art equipment, machines, and this is quite also important for us to have a kind of confidence and a proximity with the supplier. And then, of course, a lot of type tests have been performed on the product before the official sales release in 2019, to make sure that the smartCOUNT can withstand the same duty, the same stress than the surge arrestor. For example, the charge transfer, the TOV capability, the weather edging test. It must be also safe for UV light, as we mentioned before, and for temperature up to 60 degrees. We have done some tests higher, but we specify 60 degrees in relation to the electronic components. Yep. So, and if you have question about type test, I'm sure that Philip will be happy to answer. And of course, every device is routine tested for the power supply operation, for the sensitivity of impulse current measurement, and of course, leakage current accuracy. And very, very important also to make sure that the transponder pad can communicate properly with the smartphone and that the information can be collected. So this is done on every unit which is shipped out of the factory. So now we come to the conclusion and maybe some words about the evolution of the smartCOUNT. So important statement is that we are convinced that today we can detect risky, unsafe surge arresters in a reliable way, in an efficient way. So this is a reality today. It works. We are providing effective and meaningful indicators that helps to take decision. From my experience in the surge arrestor industry, it's always a kind of challenge when you install a monitoring device and then you have some values and you don't know what to do with those values. So this is important. If you have a look at the user guide, if you read some technical papers that Philip Raschke made, we are trying to give you some rationales to take decision based on the current values and especially the trend of the currents, the patterns of the currents. So for us, it's a proven solution because we have enough experience feedback from the field with various climates in many different countries with a lot of stress. And I mean, we have been through difficulties during the development of the smartCOUNT. Therefore, today we can say that we are confident with the reliability, and we have more than 600 units which are installed worldwide since the first pilot project. Yeah, as I mentioned, this is self-powered. There's no maintenance required, no battery, anything like that. The smartCOUNT is self-powered by the leakage current of which is flowing through the surge arrestor and through the ground. And as I mentioned before, it's an affordable product. Don't think it will cost thousands of dollars. It's not the case. It's an affordable product which will not be more expensive than the surge arrestor, and it also helps to allow large-scale installation. And we can use those devices on every brand of every type of surge arresters, even on distribution class, even though it's not very common to see it on distribution class, because then there is really a challenge regarding the cost, because distribution class are really, let's say, a cheap product in general, not always in general. But yeah, the interoperability is important to be able to install the device on every zinc oxide surge arrestor. And last but not least, and this is also a kind of not a breaking news, but a kind of exclusive information. We are going to make an evolution of this smartCOUNT. One of the complaint we have with the existing solution is that for the data collection, you need to go to the substation and to transfer the data to the cloud. So we are aware of that. And actually, 5 years ago, we we were fully aware of this, but it was a decision to be made on purpose, I would say. The most important thing for the development of the smartCOUNT was the reliability of the sensor, and we knew that in the coming years there will be a lot of changes, a lot of evolution in the wireless communication, and this is what we are seeing today in the industry. So we are gonna make a smartCOUNT 2.0, an evolution of the smartCOUNT, which is let's say fully automated for the data collection by using LoRa technology. And we know that many users are expecting this. Yeah, also one, yeah. So that's all. Timing is good, so thanks a lot for your attention. I'm sure that there are a couple of questions. I will hand over to Philip. You've been answering a couple of questions, I guess. Maybe you'd like to answer those questions on live, that maybe it will also answer a question of different participants.
Maybe one question I can give back to you, Florent. At first, thanks for the nice presentation. I'm happy to have a successor for those webinars now. There is a question about the upcoming smartCOUNT version with automatical data transmission. Any idea how soon it will be commercially available?
Well, not in 2022, but most probably in 2023. As you know, it's difficult to provide accurate date today, but yeah.
The reason for that is that we will not commercially provide the device before we are absolutely certain about the quality. Normally, we take our time to conduct a bigger pilot series and installation on site in different applications, climates, and so on, to run a pilot test. And after successful testing, we will release the commercial version. So that's why we don't promise that it will come in 2022, but most probably 2023.
And maybe we can also say that, and this is actually important information. We are, in the audience, if there are utilities, users, companies which are very interested in that application, especially with the evolution with LoRa technology, we are looking for a pilot project. So if you want to have some installation in 2022, it's of course possible. But we need to, this is something that requires cooperation between manufacturers and utilities users. So we are looking for a pilot project. We have some already, and we are looking for much more, because for us it's the best way to release officially a product in our portfolio, is to get the field experience and the feedback that this is reliable.
There is one more question from Branislav about the access to the smartCOUNT and to the smartCOUNT cloud. Let me explain before I answer on this question. What we are offering to the customers and to the utilities is the possibility to create accounts on our cloud. 1, 2, 3, 4, doesn't matter. With each account, you will have a login data. With that, you can log in also in the app of the smartphone or any mobile device you are using for configuring and reading the smart counts. There can be, and furthermore, if you are configuring a smart count the first time with this account, the smart count will be personalized together with this account. What happens then is a kind of cryptic algorithm that is linking this certain smart count device to this account. Nobody else except the owner of the authentication data of this account is allowed to pick up data from the smart count, is allowed to reconfigure or to even to erase the configuration and the data from the smart count. Also, only the one with this authentication data is able to log into the cloud. So this is very safe. And this also gives you the possibility to protect your installed smartCOUNT devices anywhere in the field against any data tamper. If you have multiple arresters installed on different locations, it is of course possible to use this to build up a kind of hierarchy who is allowed to read which arresters or which smart counts and who is allowed to maintain the smart counts, for example, in one location, on one substation or wherever. And you can also give another another person in charge, another account only with his arresters, with his smart counts on his location. So you can build up a kind of hierarchy. If you don't want that, you can also put all the arresters which belong to you in all substations which belong to you in one account, and you can filter and work with that. There is only one limitation with this function. If you are a kind of supervisor and you have different locations and different people with smartphones who are responsible to read the data, and you don't want them to interact between those locations and between their responsibility areas. But anyway, you want to have the complete overview about everything in your hand. This is not possible with our system. Then we would make it rather unsafe. So you as supervisor with, let's say, 10 people responsible for 10 different areas, you would have to give them 10 different accounts so they can't interfere with each other. So actually, this is the way how we believed that it will work. And until now, it worked very fine. If you have another approach on that, if you have another wish, we can think about this. And the nice thing is that our cloud is an online software which we can change, adopt, improve every time, and it will be broadcasted to everybody using the smartCOUNT cloud. You don't have to install a new software if there is an update. So if there is anything how we can improve our account hierarchy, we are open to do that, but we have to take care that it still stays safe. I hope I've been clear, because this is a real important question. You always have to keep in mind that we as a supplier of such devices have to make sure that your data is safe. And with each new level of access, we will we will open up more possibilities to for non-safety on the system. So what we want to do is to provide maximum safety on the system. And that's why it's up to you whom you are giving your authentication data for your account or accounts. I hope I've been clear. Okay. So there have been many interesting questions in the webinar, and I guess we still have time, Florent? Yes?
Yeah.
There was one important question from Mubarak. If we can install the smartCOUNT on existing arresters without any modification. So I would say this is one of the greatest strengths of smartCOUNT. You can take it and you can install it to any gapless zinc oxide surge arrestor if you want. You have to make sure that that it's mechanically fitting. There has to be an insulating base on the surge arrestor. Otherwise, the leakage current is not flowing through our monitoring device. And depending on your safety rules, you can switch off the voltage and take off the ground lead and install the smartCOUNT in between. Or what we have also seen is that the insulating base will be short-circuited, and then it was allowed to work directly under voltage. So actually there was no shutdown of the voltage, and smartCOUNT has to be installed successfully. So it's all the time a question of the existing geometries of the installation, how you apply the device. But in principle, you are able to install it to any kind of make of zinc oxide surge arresters. Subsequently, you will just change the configuration according to the connected surge arrestor, and the smartCOUNT cloud will make the whole work for you. It will calculate the data according to the connected surge arrestor class. One more question was about the limit values, the current thresholds we are giving in the smartCOUNT cloud. So what we have to say, one limitation, is that we are only giving those the resistive current threshold for Tridelta arresters, because we know how our arresters have to work under healthy condition. So we are also able to give those values. Of course, we don't know for other brands, but therefore it might be a possibility to open this this function for the utility to enter this value by their own, just by checking, okay, what is my standard resistive leakage current under normal operation, maybe when I begin, maybe when I freshly install the surge arrestor, and then I set the limit by my own. We have not included this function yet, but I think it makes sense. And if you are interested in that, I think it's makeable within a short period of time. And then also this limit function for other brands than Tridelta would be available. Here, Florent is showing how it works, how you can blind out all the different curves. Here, the red curve is the resistive current limit that is coming from the smartCOUNT cloud. Maybe you can scroll up. Here we have a SPKC0 class SL, and we know which maximum resistive current we can accept. And if the resistive current is exceeding this value, the cloud will give you an alert per email and tell you, okay, have a look at this surge arrestor, have a closer look, something is wrong. And then secondly, we have this this area where we can type in the limit value for the peak current. We left this open for our customers because typically this will be used for pollution monitoring. The typical use case is that utilities in high pollution areas are interested in the information about when they have to go to clean their assets. And this can be related to the surface current we are recording. So what I have seen in the out there in the world and the different installations, that people have set this limit pretty close to their standard peak current, which is flowing under normal condition. And then they had some rain effects, slightly higher peak currents, which led to an alert on the surge arrestor, which led to misinterpretation. So finally, they had to set this value a little bit higher. And then they were able to distinguish between standard operating condition, rain effects, and something like that, and real contamination, real current increase due to contamination. So therefore, this function has been implemented. So you can select your maximum peak value depending on your standard operating conditions, current under standard operating conditions.
So there is one question from Daniel Zandberg. You mentioned the development of the ability to collect data in the future for the smartCOUNT. Was it via LoRa? Yes. Correct. There was also a question about transmission line arresters. So you've seen on the slides, maybe I can go back to those slides. Here, so for example, in this transmission line in Vietnam for 110 kV, Philippe, you can see on this line that there are the utilities, they have installed quite a lot actually, many smartCOUNTs to assess different brand of line arresters. Actually, I would say the answer could be yes and no. I mean, technically, of course, you can assess the condition of the arrestor for non-gap line arresters, of course, not for externally gapped because there is no leakage current. But for non-gap line arresters, the principle is exactly the same. You can connect the ground lead to the smartCOUNT, and then you have 30 meters maximum length between the sensor and the transponder pad at the bottom of the tower for the existing version. So technically, of course, that's the case. Many smartCOUNTs are today assessing non-gap line arresters. But yeah, let's say the motivation for doing such things needs to be, I think, understood properly, because if you are looking at substation and variable assets like power transformers, it's quite clear, right? You want to have the confidence that your surge arresters are protecting your equipment. For line arresters, it's a little bit different because you want to prevent flashovers on the insulators. So if the surge arrestor fails, there will be there won't be a major impact like it would be the case in the substation. In general, for line arresters, you're not protecting a specific phase on a specific tower. You are protecting a section of the line or a complete line on different phases. And the purpose is to improve the lighting performance, the overall lighting performance, the number of outages, of lighting induced outages. And yeah, if one arrestor fails, of course there is a reason for the failure, but if it fails, the impact is not that huge compared to a station class arrestor in the substation. So it's always important to keep in mind, yeah, why do I really need to monitor? Because it could be, especially for transmission line in remote areas, it could become complex. The monitoring itself could become complex, but you can also learn a lot by collecting those data, and this is what the utility is doing here. And one of the, I mean, there are two motivations for them is to collect statistic information about the lightning activities, and of course also to have a kind of a clear indicator that the arrestor is still functioning.
So last question, I want to go a little bit deeper is, can we install smartCOUNT on distribution class arresters and on medium voltage? Yes, that's possible. We have this limitation that we need the leakage current to charge up the device. This is typically around 200 microamps that is necessary to charge it. And normally this covers all applications from DH up to from DH up to station high. So all the typical cases are covered, and of course we can install it on a 33 kV arrestor, just as on a arrestor on the 110 kV line. The voltage doesn't play a big role in that case, and the precision is the same. So if there is a necessity to monitor arresters of medium voltage, then yes. The only question is the application that important that you have to monitor those surge arresters? Sometimes it's not really urgent to monitor such arresters, but if they protect a line which needs to have a high availability, low downtime, then it starts making sense to monitor also those small medium voltage arresters. So yes, there were a lot of questions, and luckily also some deep technical questions. And I think one important question we can mention here is how we do testing on the smartCOUNTs. So routine testing and design testing, and you had a nice slide about that. Maybe you can open it again. This came as a question. So here on the right side, we see that several tests have been conducted which are related to the standard operating conditions of a surge arrestor, typical duties that the surge arrestor has to survive, also the smartCOUNT has to survive. So there are several current wave shapes that have been tested, discharges up to 100 kA. We have the same duty from QRS test and TOV tests applied to the smartCOUNT, weather aging tests and UV stability tests and some temperature cycling tests, IP protection tests, everything that is necessary to verify the operation under severe conditions. And then, of course, it is necessary to perform routine tests on each single device that is produced. And therefore, we are looking very closely to the function of the device regarding the impulse current record sensitivity, about the accuracy of the leakage current measurement, about the operation of the transponder pad, and the power supply of the smartCOUNT. And this is done by the manufacturer, as this is mentioned here in the slide on the left side. Very modern and up-to-date production and test methods. And I think this is one of the outstanding arguments for smartCOUNT, that we are producing with 100% routine tests and 100% quality. Other questions came up regarding the resistive current measurement, why it is based on third harmonic content and where this relation comes from. I think there are many information about that in several presentations for us, and also I can refer to our handbook, to the smartCOUNT manual that is available on the page smartcount.info. you can just download and read through. There's a big section about leakage current theory where you can read and try to understand. Here is Florent is showing the link. Here on the low end side, there's the user guide you can download, and it's multiple page document. Don't be scared to read, but there is a section which nicely explains the relation between third harmonic and resistive current. I think the people who are looking for explanations are going to find the necessary information. Anyway, there's the slide here. So it's a frequency evaluation of the wave shape of the leakage current. So what we see here is a leakage current from a surge arrestor with elevated power losses, which results in a higher resistive current, which results in a high current, in a high content of harmonic currents inside the signal. And you will extract those harmonics by frequency analysis, fast Fourier transformation algorithm. You extract the third harmonic because the third harmonic is the next higher frequency to the fundamental frequency, and this is strongly linear related to the power loss. And next thing we are going to do is we are relating this third harmonic by a surge arrestor VI curve model to the calculated resistive current. So you always need a surge arrestor model behind that. And this is very nice with the smartCOUNT. If you have a Tridelta surge arrestor, you will have all those models in the back end of the cloud, and the calculated resistive current is always precise.
I would like, just before we continue with the questions, I would like to make one, let's say, one question for the audience. I take this chance because we got, let's say, an important question from our friend Mr. Tao from Vietnam about the evolution of the smartCOUNT and how will be the communication protocol. So we are very interested, especially from the utilities side, from consultants and users. And there are always a discussion about the compatibility with the SCADA system. Do you want your surge arrestor to be on the SCADA system? Is that really something that makes sense? As you know, the brain of these monitoring devices is the cloud itself, right? And this is actually the added value of Tridelta Meidensha, all the experience we have collected. And we are quite interested to know your feedback about this and how you see the evolution of monitoring in your substation from the different countries. Is that something where you would like to have the let's say the connection with the SCADA system, with the IC protocols 61850, which is very often mentioned, or there will be anyway an evolution with the digitalization, with some typical API to connect the cloud to your SCADA system, because today, let's say, it's quite common to have a direct connection either with optic fiber or Ethernet cable inside the substation. And this is actually some information, because we believe since the brain, the intelligence, all the calculation that provides alerts, a notification, and for the configuration of the smart counts, that this is not something that can be configured by every utility. So every information, please, you can put it in the Q&A, or you can send it to us. It will be really appreciated. Philippe, is there any specific question you would like to address live?
There is a question: do we collect the data obtained by users of smartCOUNT? We are offering a database. This is the back end of the smartCOUNT cloud, where all this data is stored, but in a cryptic way. So what we are doing is, in Germany, we have to protect the users regarding their user data. There's a German law that forces us to encrypt all the data that is coming from the customer. So there is no customer related data we can see. But what we are doing is we are having partners, customers, where we are cooperating strongly together, where we have access to their data to learn and to get experience about typical applications of the smartCOUNT, together with surge arresters under different environments and of different brands and of different ages, and where we are able to study and furthermore to interact if there is something suspicious. And that's when we found out those for us great information. Of course, for the customer, not such a great information if we detect a faulty surge arrestor, but for us it's great because it's a scientific finding. And yes, this has to be highlighted because with the during the smartCOUNT development, we had many utilities all around the world offering us to access their accounts and to see their smartCOUNTs working with their surge arresters. And it has been turning out to be a very successive, because many old surge arresters have been found suspicious and exchanged against new surge arresters to prevent them from failing preemptively.
Philippe, there was questions that you answered during the presentation about the high resolution infrared camera, about temperature measurement. Can you maybe elaborate a little bit on this?
Yes, why not? So at the very beginning of the development, we are asking ourselves which possibilities we have to detect faulty surge arresters, or to measure or to evaluate the status or grade of degradation of the surge arrestor. One thing was infrared imaging, and this is a worldwide used method, I would say, to detect faulty electric components regarding their power loss, because power loss always means temperature rise. And we've been working together with a consultant who had much knowledge about this kind of measurement beforehand, and also with a couple of customers that are using infrared cameras to detect their equipment if it's faulty. And our studies came to an end when we talk about surge arresters that are placed in warm regions where the outside temperature normally is the same like the inside temperature, or where the sunlight greatly affects the measurement because the surge arrestor housing takes on a very high temperature that's even higher than the core, than the zinc oxide of the surge arrestor, which makes it hard to define what's good and what's bad. The only thing what we found is that it is possible to compare three surge arrestors of the same make standing beneath each other on the same system, and to measure the temperature, surface temperature. You always measure surface temperature on a cold day, because then the sensitivity is very high, and then you will greatly see differences between those three surge arrestors. Maybe also local hotspots produced by one failed block or two failed zinc oxide blocks, and this gives you a value. But continuous condition monitoring doesn't seem to be possible with thermal imaging. There's a question how we are connecting the smartCOUNT. If we can show it. Maybe you can open the manual. So of course there are different ways to connect smartCOUNT to a surge arrestor, and this mainly differs depending on the application. Here we have a standard station class arrestor, where we are using an adapter plate to fix the arrestor on the pedestal, where the smartCOUNT has been mounted directly on the adapter plate. And the special thing here is that it was a retrofit. We just had to loosen the ground cable, to bend it a little bit on the front, to position the data logger on the adapter plate connected to the arrestor ground flange. Of course, everything has to be insulated to ground. Then to connect the data logger and to connect back the cable that is going straight to ground. And then you have all the currents flowing through the smartCOUNT. There are a couple of other applications and installation options we have already made, but generally you have to connect the data logger to the ground of the surge arrestor, and then the ground of the data logger straight to the ground. You can also use a cable that goes down to the lower side of the pedestal and connect the data logger to the lower side, just as it is done with typical surge counters. This is also possible, but we have to make sure that it's nice insulated, because the longer the ground cable is, the more inductive voltage drop it will have. And of course, it's a matter of security when the data logger is installed in a height where you can touch it. So that's why we propose to mount it directly on the arrestor base, on the flange, on the adapter plate, or whatever.
Philip, about the current sensor, can you describe the technology of the current sensor?
Well, I think that's kind of company secret. We don't tell everything we are doing. It's much work inside. It's
so the question
many
from
years
Gerard
of
is it current sensor optical?
I don't think so. We are not working with optical current sensors. No.
Okay. Yes, there was also a question about the, let's say, the evolution with wireless communication, which is gonna be LoRa technology, long range. Yeah, and the NFC connection is the method which I use today for the communication with the smartphone, and we are doing this transition. And the NFC is suitable for high voltage devices, at least for the surge arresters and the experience we have. Okay, Philip, any other questions that you've answered during the presentation you would like to?
Oh, I'm just looking through. It has been interesting questions, and I was really having fun in answering. Let's have a look. What else we have to? What
So
we can share.
There is a question from Oscar Barbosa. Hello, what kind of acceptance tests are applicable to the smartCOUNT? Is there any standard about the matter? So that's a good question. There is no guidance. There is no standard for monitoring of surge arrestor, and I think it's also the same for many high voltage equipment. But for the reason you don't have standards is also that you have different solution from the different manufacturers, and yeah. So when we talk about acceptance tests, it's something that should be specified, that can be specified by the utilities, by the users, but there is nothing very yeah, there is nothing which is defined in the standard set. Basically, acceptance test could be repetition of routine tests, right?
Why not? So of course we make everything possible for our customers. There was another question if we can use the smartCOUNT for GIS search counters. I think the question was GIS search arresters. Florent, you can answer best. You sold. It's not long ago.
Yeah, well, actually, it's a short answer, yes, and this is actually very convenient for GIS search arresters. One of the reasons is that the first generation of counters that were, let's say, monitoring devices that were sold by our competitors are using solar panels, and very often GIS search arresters are installed indoor. So this was kind of problematic. Yeah, nevertheless, yes, of course, you have the possibility to install them on the GIS application, and it's already the case. We have a couple of different projects. So we will finish a little bit earlier, then people can go home or continue working. Okay. Okay, then we will. Oh, last one. So there is a question about the GIS application. So for GIS application, will you take the voltage signal from a tap link? So the smartCOUNT or any search counter is connected in series to the ground lead. So you just apply the same principle on a GIS search arresters, where actually the GIS enclosure represent the grounded the grounded part, and maybe we can share some pictures of installation.
But what you actually need is a certain insulated tap that is coming from the inside of the arrestor to the outside to mount the smartCOUNT on it. I think there are different models and makes of GIS arresters offering such a tap or not, but it's absolutely mandatory to have this leakage current tap to mount the smartCOUNT and then to ground it finally.
Yeah, to make sure that the current flow through the counter. Yeah. Okay, so thanks everybody. Feel free to contact us if you have more questions. Okay, we take the last question. My question was related to safety issue: the short circuit current that flows in the ground loop in case of the end of life of such arrestor occur damage in the surge counter. Well, we can say yes. Of course, you have different scenarios, but since a surge arrestor is not designed to withstand short circuit, it has to withstand the short circuit. It has to fail in the safe mode. This is the same principle for the smartCOUNT or the surge counter. You don't want your surge counter to withstand the short circuit, but you want to make sure it does not explode. So we have not done any specific tests, but we had a field experience where we have seen that it's pretty safe.
Oh, what you might not know is that we have done tests, yes, and we have experience with the smartCOUNT failing in a safe way, breaking down just like the surge arrestor. So what the standard describes, that the surge arrestor is allowed to shatter, but it shatters in a circular area which is limited by a fence, and all parts are allowed to drop within this fence. This also applies to the smartCOUNT. So we have made sure that every test that has to be withstood by the surge arrestor is also withstood by the smartCOUNT. So you're not going to take it again and mount it on another surge arrestor. You rather pick the pieces from it and put it together again, but it's not going to work anymore. But it really depends on the current, amplitude, and the duration, how big the result of the defect to the arrestor and the smartCOUNT is. But basically, we can make sure that it shows the same behavior like the surge arrestors or better. So there is no safety issue that is bigger than the safety issue that's coming from the surge arrestor by itself. If you have seen what a short circuit does to a surge arrestor, you know what we are talking about. But you can watch this in another webinar session of us, where we talk about surge arrestor selection and design. Okay, now the questions are coming.
You want to answer? Yeah. Maybe you can answer about the device, but the question is about the temperature, the maximum temperature, which is say tested up to 60 degrees, and the question is whether a counter operates above 60 degrees. But I'm wondering where do we have 60 degrees? Unless in a not in the let's say air Not outside, not outdoor, but maybe in a special application.
Maybe when it's already very warm, when the ambient temperature is high and sunlight comes in the game, then it can go hotter. The surface is black of the smartCOUNT, so it will heat up quickly. And of course, we have checked this, and it works also up to 80 degrees. But we will not guarantee up to 80 degrees because this is a kind of military temperature for electronics. So 60 degrees is the guarantee value.